In this video, we're going to take a look at modulus argument form of a complex number. Let's say we've got a complex number z here. Okay, so I've got a complex number z. Let's write this down here. So complex number z. And let's say the modulus of z we can write as r. So the modulus of z here is equal to r. And the argument of z here is equal to theta. Then we can write this complex number z in modulus argument form. So if you know the modulus and the argument, you can write a complex number in Mod-Arg form. Okay? So in Mod-Arg form, what we would get here is z is equal to r multiplied by cosine theta plus I sine theta. Where obviously r here is our modulus and theta here is the argument of z. Okay? Now, there's some interesting properties that we can use here. So if we can write two numbers, so two complex numbers in modulus argument form, then we can easily manipulate those to find some quick facts. So for example, let's say we've got z1 and z2. Okay, and these are both complex numbers. Then the modulus of the product of these, so the modulus of z1 times z2, this is equal to the modulus of z1 times the modulus of z2. Okay? And we have another similar property for the argument. So if we've got the argument here of z1 times z2. It's not quite the product here, it's the sum. So it's going to be the argument of z1, the argument of z1 plus the argument of z2. Okay? And we can also do the same here for division. Let's say we're looking for the modulus here, yep, of z1 over z2. So again, just using these same complex numbers here, and we can write this as the modulus of z1 divided by the modulus of z2. Okay, like so. And then finally, if we're looking for the argument here of the division, so for the argument of z1 over z2, like we said, we can write this now as the argument of z1, the argument of z1 minus the argument of z2. Okay? So that's everything we need there for our introduction to modulus argument form. What we're going to do now is just take a look at some practice questions, just so we can practice everything that we've covered here, modulus argument form. So if we start off with question 1 here, then we're asked to express a complex number 3 plus 3i in the form r cos theta plus I sine theta. So this here, this form, remember this is just Mod-Arg form. The first thing that we need is r. Remember this is the modulus. So for r here, and this is just simply an application of Pythagoras. So it's going to be 3 squared plus 3 squared. So 3 squared plus 3 squared. In that case, then what I'm going to get here is the square root of 9 plus 9, so that's the square root of 18. We get the square root of 18, and I can simplify this third here. I can write that as root 9 times root 2, and root 9 is equal to 3, so we get 3 root 2 there. Okay, so that's the modulus to begin with. What we also need now is the argument of z. We need arg z here. Now you don't have to, but what I'm going to do is I'm just going to quickly sketch this complex number here on an diagram diagram. So I just say that's my imaginary axis. And this is my real axis here. And the complex number z here, 3 plus 3i. So we go 3 units along and up 3. Let's just say it's roughly there. Now if I also draw the corresponding vector, we get something that looks like that. But what I want now is this angle here, which I'm going to call alpha. So to find alpha here, just some basic trigonometry. So arg z is equal to alpha, which is tan inverse of 3 over 3. It's tan inverse of 3 over 3, which is simply going to be 1. So tan inverse of 1, which in this case would give me pi over 4. Okay, so we get pi over 4. So we've got everything we need here now. We've got the modulus, we've got R, we've got the argument here. All we need to do now is put it into this form here. So in that case then, our complex number Z is going to be equal to R, which is 3 root 2, times cos theta, where theta here is pi over 4. We get cosine of pi over 4 plus I sine pi over 4. Okay, and there we have it. That's our solution to question 1. Moving on to question 2, now we're asked to express a complex number Z, which is in Mod-Arg form here, in the form x plus iy, where x and y belong to the real numbers. So working backwards then, so we've got a complex number in Mod-Arg form, we want to express it in the form Z is equal to x plus iy. It's actually quite straightforward. What I need to do here to begin with is take this cosine of pi over 3 and sine of pi over 3 and evaluate those. So if we do that down here, Z is going to be equal. We'll keep the 2 here on the outside, so we get 2 lots. Well, if you put into your calculator cosine of pi over 3, what you should get is a half. I've got a half there. Do the same now for sine of pi over 3. So sine of pi over 3, put that into your calculator, and what you should get then is root 3 over 2. I've got I lots of root 3 over 2. So now what I want to do here is just times through by this 2 on the outside. So Z is equal to 2 times a half, so that's 1. And then I've got root 3 over 2 times by 2. Well, those 2's will just cancel. So what I'm going to get then is 1 plus I lots of root 3. And notice here, this is actually just our solution. So question's done here. What I've got now is this is in the form Z is equal to x plus I y. Okay. In this case then, my x here is equal to 1. And my y would be simply root 3 there. Okay. And there we have it. So that's our solution to question 2. And to finish with here, we just take a look now at the very last question. I've been given 2 complex numbers, so I've got Z1 and Z2. Now before we attempt part A and part B, we have a slight issue, and that is the fact that Z1 here isn't actually in Mod-Arg form. What we need to do is just rewrite Z1 such that it's in Mod-Arg form. We'll do it under part A here to begin with. So for my complex number Z1, the issue here is I've got R cosine theta minus I sine theta. Whereas it should be in the form here that we can see for Z2, so R cos theta plus I sine theta. So what we need to do here is use the properties of odd and even functions for sine and cosine. So we can write sine here. So if we've got minus sine theta, then we can write that as sine of minus theta. And if we have cosine of theta, then I can write that as cosine of minus theta. Okay, so in that case then we can rewrite Z1 here into Mod-Arg form. This will be 2. Obviously the modulus won't change here. So now it'll be cosine of minus pi over 4 minus pi over 4, and it will be plus I sine pi over 4. Okay, so Z2 is fine. So if I just write Z2 underneath as well, just so we've got it here, that's 3 lots of cosine pi over 2 plus I sine pi over 2. Okay, so for part A then, if we want to find the modulus here of the product Z1, Z2, or the modulus of the products here, remember we can rewrite this then. So this will be the modulus of Z1 times the modulus of Z2. So the modulus of Z1, well, that would be 2. And the modulus of Z2 here is 3. So we get 2 times 3, which would give us 6 there. Okay. So the modulus of the product here, Z1, Z2 is equal to 6. That's part A done. And for part B, we're asked to find the exact value of the argument of the product Z1, Z2. So for the argument here, the argument of Z1, Z2, remember this time now we add these together. This will be the argument of z1 plus the argument of z2. So the argument of z1 here, that is minus pi over 4. We've got minus pi over 4 plus the argument of z2, which is pi over 2. So what I've got here then is minus pi over 4 plus pi over 2. So in that case then we just simplify this here. This is the same as 2 pi over 4 minus pi over 4. Like I say, if I just write this out in full, 2 pi over 4 minus pi over 4, which would give us pi over 4 there. Okay. Remember, we want to give this in its exact value, so pi over 4 there would be our solution to B. And that gives us the solution there to question 3 overall. So that brings the end of this video on Mod-Arg form. In the next video, we're going to take a look at the locus of a complex number.